Hello, uh, welcome. I want us to look at the concept of the equation of a straight line. Any straight line can be represented by an equation in the form y is equals to mx plus c. Now, y, these are the values or the quantity that is plotted on the y-axis. This y-axis is also referred to as a vertical axis, the vertical axis. Then we have the x. These are the values for the quantity that is plotted on the x axis, sometimes refers to as the horizontal axis. The horizontal axis. And this is taken to be the slope or the gradient of the line. Then C is given the time the y-intercept, and it actually means the point where the line cuts the y-axis. The first step is to write the equation or reorganize the equation in the standard form such that y is on one side of the equal sign, then the other parts of the equation are on the other side. It's like we're trying to make y the subject to the formula. So we're going to have 2y is going to be the same as 4 plus 6x. We can rearrange this to look like 2y is the same as 6x plus 4. If we divide through by 2, we will have converted our equation into standard form. We are going to have y be the same as 6 divided by 2, that is going to give us 3x, plus 4 divided by 2 to give us 2. So now from the parts of the equation of a straight line we had seen earlier, the slope is the coefficient of x, and in this case the slope is the coefficient of x is 3, so this becomes the gradient of the line. The gradient of the line. Then this 2 becomes the c, this c here, and we had said that c is the y-intercept. So our c here is 2, and this becomes the y-intercept. The y-intercept. At y-intercept, the value of x is 0, and that means if you have to express this y-intercept as a coordinate, then the value of x will be 0, and then the value of y will be 2. That is the solution to that example. Maybe to put this in a diagrammatic way so that it can be easily understood, the x and the y-axis. The vertical axis we said is the y-axis, the horizontal axis is the x-axis. So we can sketch that line. The line for that equation look like this. Y is equals to 3x plus 2. So this is the y-intercept. The y-intercept where the line cuts the y-axis, and you see the coordinate is going to be 0, 2, and then the slope of this line, the gradient of this line, to be the change in y over the change in x is going to be 3. This 3 here. When we liken this equation to the standard form, the line which is mx plus c, the c becomes 2, the y-intercept, the m which is the gradient will be 3, and now we'll be able to extract the lines, the values of the gradient and the intercept from the equation straight away. But for instance, note the equation must be written in this form: y is equal to mx plus c before extracting the slope and y-intercept. You can look at now that you have seen the form of the equation of a straight line, you can say how can we be able to form equations of straight lines. Formation of straight line equations. I want to split this into 2 cases, and I want to start with case 1. Case 1, when you are given 2 points on the line, 2 points on the line, 2 points on the line. Let's look at an example. Find the equation of a line passing through points A, 0, 2, and B, 0, 4. So solution: step 1, let's find the gradient of the line. Let's find gradient of the line. Gradient of a line is given by change in y over change in x. Change in y is given by getting the y in the second point minus y in the first point, while the change in x is found the same: x in the second coordinate minus x in the first coordinate. So in this case, our slope or the gradient g will be given by at b the value of y is 4 and at a the value of y is 2 divided by change in x. At b the value of x is 0 and at a the value of x is, let me adjust this point here. The point here, that will be, this point be 1, 2, not 0. So this will be 1. So at b the value of x is 0 and at a the value of x is 1. So this will give us a 4 minus 2, this will give us 2. 0 minus 1, that will give us negative 1. So the gradient will become negative 2. Step 2. Assume another point x1 on the same line, and express the gradient using it and any of the two given points. Any of the two given points. I'll use, for my case, I'll use the point xy and the point 0, 4. So the gradient is going to be given by y minus 4 over x minus 0, but the gradient had been found to be negative 2. So we replace negative 2 with the same as y minus 4 over x minus 0. So this will give negative 2x, negative 2 times x will be negative 2x. This will be the same as y minus 4. So bring 4 to the left hand side to be minus 2 minus 2x plus 4 is the same as y. So if we interchange these values, we're going to have y be the same as minus 2x plus 4. And this becomes the equation of a line that passes between the points A, 1, 2 and B, 0, 4. So in a nutshell, the process first use the 2 points. Summary. Find gradient using the given 2 points. Then step 2, assume an unknown point. Assume a point xy. Then 3, find the gradient again using xy and any point given, any of the given points, and any of the given points. Go to case 2. In this case 2, you are given, only given a point on the line and the gradient of the line. So we look at an example here. Find the equation of a line which passes through point P to 0 and as a gradient of three over two, as a gradient of 3 over 2. So now the solution because we have a point P, we have the point P 2 0 and we have the gradient 3 over 2. The next step is assume a point on the line that is not known, that is xy. So now using these 2 points P and the xy, we write an expression for the gradient and then we equate to this gradient. So we say that gradient will be given by changing one over changing x, and this is going to be given as g is 3 over 2, and the changing will be 1 minus 0, because the value of y is y, the value of y at p is 0. This will be the same as x minus the value of x at p, which is 2. Cross multiplying, we're going to have 3x minus 2, 3x minus 6, 3 times minus 2 b minus 6 will be the same as 2 times y b minus 2y. 2 times 0 will be 0. So this will give us 2y be the same as 3x minus 6. To write this in standard form, we will divide through by 2, and then we're going to end up with the equation as y is equal to 3 over 2x minus 3. And this becomes the equation of the line that passes through the point P 2 0 and has a gradient of 3 over 2. So now we look at how can we be able to form equations of parallel lines. The first thing to note here, parallel lines of same or equal gradients. That's the main bottom line that we're going to be employing in this case. So let's look at an example here. An example. A line L passes through the point Q 0 2 and it is parallel to another line whose equation is y is equal to 2x minus 16. Find the equation of line L. So here we're going to use the logic that we had talked about. The parallel lines have the same gradients. Now from our earlier discussions, we had seen how to extract the gradient of a line from its equation. So from the given equation, we are going to be able to extract the gradient, and that gradient will be equivalent to the gradient of line L. So let's see the steps that are going to lead us to that solution. I need to create some space here. Solution. The given equation is y is equals to 2x minus 16. So gradient of this line is going to be equal to 2. Therefore, the gradient of L, the gradient of line L is equals to 2. So now we have a point where L passes through, so it is Q, which is 0, 2, and then it has a gradient of 2. So the next thing, we just assume an arbitrary point that is on line L, and because it is not known, we call it xy. So we're using these 2 points, the assumed point and the known point, and we write an expression for the gradient, and that expression we equate it to 2, which is the gradient of the line L. So 2 is equal to y minus 2 over x minus 0. Cross multiplied here, we're going to have 2x is going to be the same as y minus 2. Bring these 2 minus 2 to the side, we're going to have 2x plus 2 be the same as y, and then you can now rearrange this to look as y is going to be 2x plus 2, which will be now the equation of that line L1 written in standard form. So just like another summary, a note for parallel lines, M1 is equals to M2 by A. M represents gradient, represents the gradient. M represents the gradient. We've looked at parallel lines, and now I want us to see how we can form equations of perpendicular lines. Equations of perpendicular lines. Equations of perpendicular lines. So now we have seen that the gradients of parallel lines are equal. But now what is the relation between the gradients of perpendicular lines? So we will write this as a note. If two lines are perpendicular to each other, to one another, then the product of their gradients is -1. So if we take M to represent gradients, so M1 will be gradient of line 1 multiplied by M2, the gradient of line 2. This has to give you -1. That will have to give you -1. So this becomes the logic that you're going to use to be able to relate gradients of perpendicular lines. So let's look at an example here. Example. We want to see an example of calculating an equation of a line using the logic or the idea of perpendicular lines. A line PQ passes through points P -1, 4 and Q -6, 7. Find the equation of a line perpendicular to PQ and passes through point P and passes through point P. Solution. Here we have two lines. We have line PQ and we have another line that is passing another perpendicular line passing through P. So from this line PQ, we first get the gradient of line PQ. Get gradient of line PQ. P is -1, 4 and Q is -6, 7. So the gradient will be 7 minus 4 divided by -6 minus -1. The 7 minus 4 will be 3 minus 6. This should be -6 minus -1 to be -5. So gradient of PQ is going to be -3/5. But we know that the product of the gradient of perpendicular lines must give us -1. So gradient of the line that is passing through P, gradient of the line that is passing through P times the gradient of the line PQ, that has to give us -1. So this gradient of the line passing through P times -3/5, this has to give us -1. This implies that the gradient of the line passing through P be given by -1 times the reciprocal of -3/5, and this will give us 5/3. When you solve this equation here to give you that gradient of that line passing through P will be 5/3. So now we have gradient of the line passing through P is 5/3, and we have the point P where it is passing through, which is -1, 4. So now we assume another point. We assume a third point, xy, a second point that is, and now we use these 2 points to express for the gradient, which will be equivalent to 5/3. So 5/3 will be the same as 1 minus 4 over x minus -1. So 5/3 will be the same as y minus 4 over x plus 1, because multiplying will give us 5x plus 5 be the same as 3y minus 12. Move this 12 to the other side so that we are going to have 5x plus 5 plus 12. You had 12 both sides. This will give us 3y. So 5x plus 17 is the same as 3y, which can be rearranged and written as 3y is the same as 5x plus 17. Divide by 3, divide by 3, divide by 3. The equation for that line that is perpendicular to line PQ and passing through P be given by 5 over 3x plus 17 over 3, and this becomes the equation of that line. That becomes the equation of that line. Double intercept. Double intercept form of the straight line equation. When a straight line equation is written in this form, x over a plus y over b is equals to 1. This is called the double intercept form. The equation is said to be in the double intercept form, such that the x-intercept will be a 0, or the y-intercept will be 0 b. This will value become the y-intercept and this will become the x-intercept. So let's look at an example and see how you can be able to use this to get the intercept of the line using this double intercept form. Example. Using the double intercept form, find both the x and y intercepts of the line find the line closed equation is y is equal to 3x plus 6. Solution. We need to write this equation. In the double intercept form. So we first have to bring the x and y on one side. So we are going to have the equation look like this: y minus 3x is equals to 6. Then this term here, we have to make it 1. Make C1. So to make 6 1 is we divide through by 6. Divide by 6. So divide this by 6, divide this by 6, divide this by 6. So this is going to give us y over 6 plus x over negative 2 minus 3 divided by 6 be 1 over 2 be the same as 1. Because you have tried to make this one, then this equation is in the double intercept form. So this becomes the y-intercept and this becomes the x-intercept. So we're going to have x-intercept be equivalent to x be negative 2 intercept, which will mean if we express it as a coordinate, it will be negative 2, 0, where the y-intercept will be 6 and expressed as a coordinate will be given as 0, 6, and that becomes the double intercepts for that line using the double intercept form. Alternatively, there is also another way of getting these intercepts. Alternatively, for x-intercepts, let y be 0, and for y-intercept, you let x be 0. They will give you the same values. These equations of straight lines, and this is the angle formed between a line and the x-axis and the x-axis and the example. Find the angle between the line whose equation is y is equals to 3 over 4 x plus 7 and the x-axis. You can pause the video and try to solve this. Solution. The equation of the line is y is equal to 3 over 4x plus 7. So the slope m is 3 over 4, and we know that that angle is given by tan inverse or arctan the slope. So theta will be given by, using a calculator or a mass table for those who don't have calculators, theta is going to be 36.87 degrees, and that becomes the angle between this line and the horizontal.